So to review the triangle inequality theorem, just remember that any two sides have to add up to be bigger than the third. So you would get, and did anybody recognize this problem? That's okay if you didn't. But we need to write out three inequalities and just go around the triangle for that. And then solve each one for x. So like this first one, if we get our x's together and our numbers, we will have 18 and then move the 2, so we'll get 2x. And then divide an x and 9. So how do you read that bottom line that I just wrote? Yes, but we want to read these from x. Always read from x. So it says x is less than 9. Okay, so that one seems legit, like it actually gave us useful information. Next one, combine our x's, and let's go ahead and add the 3 over. So 18, and then divide by 6 to get 3. That one seems legit too. What does it say? Yeah. Okay. So that tells us that this one's probably going to be the one that is the fake one. Not fake, that's not the right word. But nonsense one. And so if I combine these, I get 12. And then if I'll have to subtract the 12. And so that is, while it's true, it's not really helpful. Because if you notice, this one says x has to be greater than 3. So it can't be true for it to be greater than 3 and greater than negative 6. Those both can't be right. Because that would, this last one would include numbers that don't get included in the middle one. So it is the nonsense result. So we kick it out. How do we write this as a compound inequality? The two that actually make sense. Remember, we have to write it with x in between two less than signs. And then we write small number, big number. So 3 and 9. And if we read this, it just says x is between 3 and 9. Can it be 3? No. Can it be 9? No, that's right. This is strictly inequalities, no or equal to lines. So none of this. Because if we actually plugged in 3 or 9, that would be the case where these two, like side length RS and TS, they just fall and touch and basically make the bottom line. Okay? So we can't have that. That doesn't make a triangle. It has to be strictly between. Any questions on that? How'd you do? You will have one of these on your test. Very similar to that. Okay? All right, these are going to be reviewing, if you notice all these tick marks, reviewing the isosceles and equilateral triangles. But this is just a linear pair. Those are still going to come up. And the triangle actually for x doesn't matter at all. It's just a linear pair. So 125 and x have to add up to 180. So what is x? Okay, and then because this is isosceles, remember these two angles are congruent. So this is also 55, which makes z also 125. And then how do we get y? Those are 110. The 3 together have to add up to 180. So 55, 55, and y. Good? Okay. And then this angle is 60. Strictly that angle. Why? It's a what kind of triangle? Equilateral. Equilateral, which is also equiangular. And so it's basically this, like all three angles are the same. So 3x equals 180. That's how the 60 comes up. So all angles in an equilateral triangle are always 60, right? No matter how big the triangle is, the angles are always 60. And then what does the box mean? 90, so that makes n be 30. And then m has to be what? if this is 30 and this has to add up to, yeah, that's good. Okay, and then this one, this is kind of interesting looking picture. So, let's see, where do you want to start? Let's start with these. If this is 50, what kind of triangle is this? It's isosceles because of these tick marks. Okay? So, what does that make these two angles I marked as congruent? Well, if this is 50, these two are equal. What's the leftovers that we have to split up from 180? Yeah, so 50 take away from 180 is 130, which means we need to divide those by evenly, so 65 degrees each. Okay? And then what else? Do you see this little triangle here? Well, I guess it's not necessarily little, but that triangle. What kind of triangle is it? It's also isosceles. And that's because of these double tick marks. Okay? Which means these angles, and I'm going to use different colors instead of more tick marks. Those angles are also congruent. And how many degrees is this one? That's 90. So what is the measure of those two red angles? Yeah, good, 45. So I'll put it down here, 45. So what does M have to be? Well, here's why. Remember the whole blue angle is 65 and the red is 45. So it's just the angle addition postulate, so adding the two together. Good. Sometimes the pictures are a little hard to see. How'd that go? Okay. Any questions on pages 3 and 4? So these proofs? I'm saying 3 and 4. It says 5 and 6 on the page, but the CPCTC proofs that look like this. Any questions on those? Okay. How about these two? That says page 6 in your packet. Please ask. All good? Okay. How about the Mr. Furwerda page? Obviously I didn't make this one, but it's a really good one. That's why I like it. Any of these? Starting on that? I know that a couple of people got stuck on the last. You guys don't have that page, right? Yeah, is this your last page? Okay. Some people got stuck on these. So at a minimum, I'd like to do 5 and 6, but are there any others that you need help with? Okay. All right, well, let's do these. These are a good review of a number of things. So remember, this is the same as statements and reasons. No expectation that you do both. So, is what we're given marked in the picture? No. And so the reason these are highlighted is I gave you the hint before last week I gave you that. But let's just make sure that this gets in our picture. So angle SFG and HGF are congruent, which is that one and that one. And it looks kind of weird with that line slashing through the middle. So here's my suggestion. And it's usually very helpful to students. And that is redraw these two triangles, not overlapping. Now we can mark that angle and that angle as congruent. It just helps you see it better, okay? And then it tells us FS is congruent to GH. So those two sides, again, in the given figure, it's helpful, but it's a little bit hard to see. But if you put it in the separated picture, it's starting to look a little better. Okay, and then keep this in mind. We always have this list of our different ways to prove. And so just go check off what you know you're not going to use. So you narrow it down. But my question, I guess I should have asked, why are we even dealing with triangle congruence if I'm just trying to prove two side lengths are congruent? So what's the theory behind that? Yeah, it's CPCTC, right? If I know that the triangles are congruent, I can say whatever piece I want to. So, are we going to use HL? No, because I'm not told there's a 90, not shown, and there's no reason to assume. Okay? I have one side length. Will I be able to get two more? Well, there's not gonna. I can get one other one, but there's no way to get two. Okay? And then down here, for each of these, I need two angles. I only know one. Is there a good way to get another two angles? So you're looking for things like angle bisector, vertical angles, alternate interior, corresponding. Like, do we have any of that kind of copy paste? No, nothing, right? So those are out. So we're going to look to do this one. All right. Let me get caught up to where we are. Bless you. All right. As it stands, we have a side and an angle. So we need another side. And it just happens that if I labeled these pictures, FG, and this is FG, that is the same exact side length. Okay, so that's why that highlight was there, because it is what property? Yeah, so we can say FG is congruent to GF, and that's by the reflexive property. And sometimes it's hard to see that in these overlapping triangles. Sometimes it just is. Sometimes it just takes practice, but sometimes it's just hard to see it. Okay, now we have that marked, and so we can prove the triangles are congruent. Why? What's the reason? Why are the triangles congruent, I mean? No, not yet.
Side angle side.
It's side angle side. Side angle side. Remember, order matters for sure. And then we can just finish by saying, hey, if the whole triangles are the same, then any corresponding parts are. And there's our CPCTC. All right. Reflexive property can kind of get you sometimes if you don't see it. Are those givens marked in our picture? No. And honestly, this picture is hard to see if you don't draw it out separately, especially when you start marking stuff. So let's try it, and I'll show you what I mean if you didn't do it. So MN, if I put a tick mark or maybe 2 here, is that MN or is that NA? You see what I mean? It's hard to tell. And then it says EN, so that's the same. Okay, am I talking about that length or the whole thing? And then NT and NA. Oh, wait. You see what I mean? Now I've overlapped my marks. So, again, if you have overlapping triangles, draw the two triangles that you're actually dealing with. And it's not imperative, but I tell students to try to draw it the way it is. So, that first one looks like that, right? It's kind of tilted. And then it's N, T, and M. And then my other triangle is sort of like that. And that one is N, A, E. Now if we start marking pieces, it becomes obvious right away, and it's really helpful. So MN is there, EN is there, NT is there, NA is there. Okay? Notice we haven't even done a proof. All we've done is redraw our picture and mark the given. Now we can go here. And I would be fine if you wrote this once at the top of your paper and just used it each time. The only thing is it's a nice visual when you get to scratch it off. So what can we kick out right now? HYHL. No. Because we hate HL and we never use it. No, it's good, but you're right. No right angles. What else? Is there anything else we can scratch off right now? I would say angle side, considering the fact that we don't have any angles, there's very little chance we're going to know 2 if we don't know any, right? Right away. Okay, what else? By the same logic, I would say get rid of angle side angle, right? That still requires me to know 2, and I don't know any. So it's probably not going to be the one we use. Okay, how about these two? Can we for sure cut any off? We do. We don't know 3 angles or 2, but we know 1. But I was going to say I wouldn't chop these off yet. The reason why is because we have 2 sides. Maybe we could get a third. We have 2 sides already, so it's probably going to be one of these 2, right? Okay. Well, now's where you have to go on the hunt. Like, I have to either find another side or an angle. If we do find an angle, which angle would we need? So use side angle side. Which angle is it? Angle N. And guess what? It's the same in both pictures. Right? As soon as you draw it out and you say, hey, I sure would like it if N was congruent. But wait a minute, it's the same angle. So doesn't it have to be congruent? Yeah. And by what property? Like, why is it congruent to itself? Yeah, it's reflexive, and we can use reflexive property with angles. So double check that your note says that. At least 2 congruent sides is this section. Did we not write that? No, that's because I'm on the wrong page. Here we go. An angle or line. Make sure yours says that so that you know you can use it. Okay. So back to this. Now we have side, angle, side. What? Oh, I named that weird. There we go. Now, what corresponds to angle N in the other figure? Because remember, we need to write it in the same order so that like N goes with whatever, M goes with whatever, and T, so it's in the right order. Sorry, what? Was that what you said?
Yeah.
Okay, let's check. E is the one sticking way out. I think E goes with M, yep, and then A goes, yeah, good. Does everybody agree? Alright, and then how do we finish off? Remember, once we have proven that the triangles are congruent, all corresponding parts are. So no matter what that last piece said, as long as they're corresponding, we can just say CTCTC. Did that help, those of you who needed that? Okay. And it was a good review on proving. So these proofs are typically like these, they're like 4 or 5 steps. They're pretty shorter ones. Early on, remember the proofs were like 2 or 3 steps in your packet. So how do you feel about this for your test? Okay. All right, so just giving you a heads up, your test is not all proofs at all. In fact, the majority of the points come from solving things like our warm-up. Okay? So I'd like to give you time to work on that review. So you're since we're having our test tomorrow. Is there any particular solving thing that we need to talk about or review? Or do you feel like you just want to work and ask questions as you go? Yes, that? Braden, you said you're done. I'll come check in with you. You need one. It's right over there. Under the quadratic. Actually, no, it's not. It's right here. I haven't put it over there yet. Does anybody else need one?